I'm going to show you how to generate Tensegrity Table with Blender Python API and run it in your website. Before I begin, quick reminder, I do a live stream every day at 2 p.m. Eastern. So visit ojambo.com and go to the Watch Many Live Summit. You can see the topics for this and upcoming tutorials. You can also join the live chat and post anything about programming or lifestyle topics. So as you can see, there's a direct link to the live stream, where the live chat will also be. And if you don't want to do that, no problem. You can simply watch the video. The video is also embedded in this article. Scroll down later and I'll show you where the video is. And also be sure to subscribe, like, follow, and leave comments, because that helps the channel grow and also to spread the word about this type of tutorials. I always use open source tools. So if you want to learn, especially DIY, and how to use these tools to improve not just your coding skills but life in general, just subscribe. Thank you for that. I'd like to thank everybody who subscribed so far this month. Keep it up. Helps me, motivates me, and I said it helps the channel grow as well. Back to Tensegrity tables. So as you can see here with this animation, Tensegrity means that you have a structure. For example, in this case, it's a table. It could be a chair. It could be something else. It's held up by what looks like a string. It could be usually it's cables, and it's interesting because, for example, if you see this table here, the tabletop is just a regular tabletop, and the bottom is just a base. But you see what it's all held up using just cables. So this makes it extremely strong because the focus is the focus is on the actual use case. For example, this is a table. Yes, it's going to be a very strong table, but you might be surprised because you think, hey, don't you need like a stronger pillar or stronger legs? Surprisingly, this works extremely well. Okay, so you can make multiple of them. I'll show you how to make one today. So if you also want to create 3D models with code and show them on your website, this tutorial is also for you because it's beginner friendly. Now you do need to know some math, but you can do it in different ways. I decided to use math because it's the fastest way to get a lot of stuff done. So basically what will happen is the structure, as I said before, it's held together by continuous tension and discontinuous compression. So that's what Tensegrity means. And then we're going to use a Python script, the Blender Python API. And then to view it in a website, we're going to use Google's awesome model viewer element, and that's it. That's it. So that's it. It's a pretty basic, simple tutorial, beginner friendly. So if you're impatient and just want to get the code, I have the code here for you. You can simply expand and grab it. This script, basically what happens is it clears the screen. As I said, we're going to use some simple math. I'll explain all that when we get to the code part, and create the positions of the three struts, creates the struts as low poly cubes, and then connects the top and bottom with simple edges, which is our cables, and then exports the final model as a GLB file. So GLB stands for GLTF. So the default GLTF is a JSON file, basic text file, and then there's another version where it will export that, but it will embed for example, if you have textures, images, embed them inside the JSON file, so the file is going to get much bigger. So the GLB, the B stands for binary, meaning that everything is there and it's just one binary file. So now, obviously, if you're trying to parse it, the JSON is easier for readable. But as I said, if you have a lot of things going on there, like animations, everything, the file will get very big. But if you know what to look for, just use the GLB file. I just want one file, that's why I chose the GLB file. Okay, and then after that, you just run Python on the command line, Mac, Linux. I believe Windows, you can do the same thing as well. You just basically -b, that's for background, -p, capital P, that's for the Python file, and obviously the Python file, and they can render everything. So there are multiple ways you can do this, but what I'm going to do is I'm going to put everything in the Python code, so then it will create a Blender file for us. We also create the export the GLB file for us. You can skip some steps and just do it on the command line, or also load up the Blender file in Blender and then export it that way. I'll show you that when we get to the coding part of the tutorial. And then to display the model in the web, I said use the model viewer, and here's the code snippet to put it there. Use a CDN to grab it, and this is it right here. And these are the screenshots. So, excuse me. Sorry, but oh, I can't believe it's actually warm here today in this room. Looks like I need to turn the heater soon and get the air exchanger working. As you can see, the screenshots here, as I said, and then this is the one I took of on the web, and I'll explain all this later. And here's the video as I promised. You see this, we're doing this live. Yeah, you see we're doing it live. Okay, so I have a folder here, and you can see I have this HDR image. This is the one that's going to give us our lighting, so we can save time on putting like a camera and special lighting, spotlights and all that. We just use this courtyard. It actually came as an EXR file. I just converted to HDR because EXR are not widely supported on the web. Because some people may be using maybe slightly older devices. From what I found out is HDR is supported by at least 60% of all web browsers as of 2024. Now we're in 2025, so that might change. Okay, so as I said, this Python file is going to generate the blend file for us and a GLB file for us as well. So I'm going to delete this because we will recreate them on the command line. And then this is the HTML file. So I'm going to open this up in the GNOME text editor. And I'll start with the HTML file just to get it out of the way. So here's the HTML file, the usual stuff. There's a doc type. Let me zoom in a little bit more. Then I put in the head section, I put a meta for the viewport, meaning that the device width. So this is usually for small fonts, small devices like the phone, so that it takes up the entire width, so it's not so tiny. And then here's the module. This is the CDN. I use unpack.com, and you see it's the Google model viewer. We just want the model viewer, and then this styling is not important, but I just put it here because I want it to be full screen and full height and full width. And then it's just an H1 tag. I just put low poly Tensegrity Table model, and here's the model viewer tag. So you see the source will be our GLB file, and I just put an alt tag here. I just put low poly Tensegrity Table. And I chose auto rotate, camera controls, AR, and shadow intensity. I set shadow intensity equal 1. Let's see the environmental image. That's our courtyard HDR image. This is the image right here. So that's it. So let's go to the Python file. That's what everybody's here for today. So I want to say something. I had to make a few changes to the way I usually export, and I'll explain to you why. It's because as you guys know, I use Blender for my video editing. Now, the problem is I use Fedora 42. That one doesn't come with H.265 because of patents. So I had to get the FFmpeg from what do you call it? I had to get FFmpeg from RPM Fusion, and then I also got the Blender version from RPM Fusion. No, the Blender was from FlatHub. The problem is because there's some restrictions because it runs in a container. It's containerized. The problem is it doesn't understand relative paths. So I had to come up with some tricks. So what I did is I did a bash alias. And that way, so if you see the command I use in the command line is different, that is not because I came up with a new it's the same Blender. It's just that I don't want to type the long way, but I want to be able to use a relative path. For example, just type Blender and this, and then the Python file, and it generates it. But I'll type the command that you actually use if you're using a regular version of Blender. Alright, so here I create some configuration variables. See the Blender file, it's going to be low poly Tensegrity Table .blend, and then the export file will be low poly Tensegrity Table .glb. So this is what I said, I had to come up with some tricks here. So you see I had to come up with a script directory. So you see I imported the OS here. You need to import the Blender Python math, vector, and system as well. So what I did is I get the path of the current file. Obviously the Python file will exist. It doesn't exist, I'll try to get it just the name of where the file is right now, and then basically what I want to do is I want to get the folder. For example, right here, this is the folder I want to grab. So I want to get the full path. So once I have the full path, then I'll be able to generate the blend file here and the GOB file. If I don't do that, by default it'll put it in my home folder, or put it inside the app Flatpak. It's usually /app/blender, which I don't want. I want it right here, relative. So I said I had to make a few changes. So with that said, the rest is pretty straightforward. Table height, I set it to 1, side length 1.5. So this here and here, and you can see the thickness, the base thickness, the strut height, the strut thickness, the cable thickness. See low poly vertices, I set it to 8, and the joint size I set to 0.4. Sorry, 0.04. All right, and then there's some other constants for Z positioning or Z positioning. What I did was the tabletop. This is on up here, the tabletop. Here, I made it the table height times the top thickness divided by 2, and you can see the rest of this math here. So I said this is all in the I put this in the Python code snippet that's above on the website of Jumbo.com. So here I have one for the base bottom, a struct center, struct top, and struct bottom, all for the Z-axis. So the first thing we do is we clear the scene. And the reason I clear the scene is, as I said before, is that by default in 2025 Blender comes with a cube, 4.5, the LTS version comes with a cube, comes with a light, and comes with a camera. I don't need any of those. And the reason I don't want to use some of them, for example, like the cube, is because in the future Blender might change. It might not come with anything, or it might come with more stuff, or it might the object might be different. For example, maybe it will come with a sphere. So if somebody wants to run this code in the future, it's going to be confusing. So that's why I clear everything. You see, I just select all of them, and then what I do is I just delete. Then after that, I have another method or function to create a material. You see, the arguments, it takes in a name, color, and metallic and roughness. For metallic and roughness, I have default values of 0.0 and 0.5 respectively. So we're always going to use a PBR material. Basically, make sure there's a name. So the name, that's what we'll call the new material. And we're going to set it to use nodes. I think that's the default now, but that wasn't in the past, so that's why we still this, just to it's more feature proof. And then obviously we're going to use the principal BSDF, and we set the base color to the color that's being passed in, metallic and roughness, and then we return the material. Then after that, we have another one which applies material. So basically you take the object and the material, and very simply it will make sure that the material exists. If it does, it will just simply append it, or we'll append it the other way, one of the other methods. Then we have another one which will create the cylinder between the points. So this is this guy here. So this little cylinder here between the two, between the tabletop and table base, or the bottom. So as you can see, we have the start. So we have the start location, end location, radius, name, and material, and the vertices, which are passed in as arguments. Otherwise, we use the default low poly vertices. And you can see we set the center, length, and then we see it says here blender python.ops.mesh.primitive.cylinder add. So that's how you add. We set the vertices, radius, depth, and location. And then we also remember that Blender uses radians, meaning that it likes everything to be between 0 and 1. For example, I'll give you an example for colors. For colors, you know, if you're using RGB, it's 0 to 255 or 0 to 128, depending on which one you use. So if for radians, it has to be 1, meaning that you need to divide by 225 or 128 to get the radius. Radians. And that's the same thing with the rotation. So, for example, you can't simply say, I want it rotated 40 degrees. You need to convert that into radians. Now, luckily, Python has a function to do that for you. And you can also use, I think Blender has some, no, Blender doesn't have one, so you have to do that. Same with the rotations. You have to rotate it, as I said before, in radians, not in degrees. Then we have another function here called create join, which takes in the location, size, name, and material. And then you see it just adds a UV sphere, and it's a low poly UV sphere, and it will add the segments and the radius. It also returns the object, just like the previous one. Then we have another one which generates the actually squared floating table. That one doesn't take in any. This is just the main, the main function that we'll call the previous one. So you see the first one, it clears the scene. Then it's going to create a wood material, a cable material, a joint material. Then we'll create the half side, base cable, top cable for the z-axis, and the base points. You see it's going to use vector. And then you see over here, so vectors are basically a way of arrays in 3D, three dimension. So that you need that obviously for X, Y, and Z. And the rest here we create the geometry, and then the cables and joints we just use a for in loop. We're going to use so that's what we do here, and then here. So after that we can save the blend file. You see we get the path, and we just join to the name, and then output will be this is going to be for the GLB file. It's the same thing, the script directory and the export file name. And then we try just in case there's a problem. So we use try here. So try in, like, for example, PHP, other language they call it try catch. Obviously in Python it's called try exception. In other languages they might call it try catch exception, but I guess in Python you skip the catch because so as I say, we try to save it. So if everything's good, we say, it's saved successfully. If it's not, we see the runtime error, and then we just output the error itself. And then we try to save the GLB file. We export the scene. You see it's GLTF. The file path is the output underscore path. Export format is GLB. Export apply true. Export materials true. Export, sorry. And then use selection equals true. And that's it. So, and then obviously in the exception part we have the runtime error, and we print that as well. And then right at the end we also generate we call that generate square floating table. So that's the code. Another reason I'm doing this type of tutorial is because a subscriber requested I do more OOP type Python. So this gives me a way to do this. Now the good thing for OOP is that I can also reuse this in the future. All I need to do, for example, is just change some of these variables, and then this one, the clear scene, is always going to be used. So materials also always going to be used because this is the base materials used. So things like that, and apply materials, simple methods you can reuse. Okay, now with that said, I'm going to drop to the command line, and be aware, as I said before, is that on the command line, I said I can't simply just type Blender because Blender really doesn't exist, and I'll explain that one more time. Here, let's make this, and I'll make it that big. Yeah, so I'm going to clean this up a little bit. So as I said before, I can't type Blender. I mean, I did make an alias, but I can't simply just type Blender. Oh, it's going to open up Blender. That's not what I wanted. But I did make an alias. I'll explain what I did. So if I type alias, it's going to show all the aliases. I'm going to zoom out a little bit. See, I create some aliases here. Where are the aliases? What is going on here? Oh yeah, here. You see aliases? You see, it basically is just so. The alias for Blender is flatpak space run space org dot blender dot blender. So I don't want to run that, right? So that's why I mean I can, and then I'll have to put the full path to something, but it's still not going to work because by default it's still containerized, so it won't be able to write. So what I did instead was I created this here. So I created Blender B as an alias. So it's a function. It's a one-liner. So basically, it will take the local path. It's a real path here. So it will get the local path, meaning, for example, it's going to find low poly Tensegrity Table, and then what it will do is it will then you see it says flatpak run or Blender blah blah blah. So it's going to run that this one here, and then you see it's going to be running in the background, and then the absolute path, and then the name of the file, and then I can add my own things after. So that's why I created it as an alias. I have another one here which I do for the, actually those are the same. I don't know what I did here. Oh no, this is for Python files. So this one is when I render out a video, and this will see P, that's for Python files. It says -p here, the absolute path, and so forth. The reason for this is because of the way Blender works. Is Blender, after you put the -b for the what do you call it, the background, it assumes it's always going to be a blend file. So but this case it's a Python file, so this -p can't be after, it has to be before. So that's why I had to do it that way. And you can see the one I was used here, clean and what do you call it, clean. That's what that one does as well, just to clean up the terminal. So that's it. I'm going to clear here. We're going to use Blender P. Now you understand why I do that. And then I just type low poly table pi, and then if you see down here, it's going to generate. You see it's done. So it generated the blend file. It also generated the GLB file. So as you can see here, it's really fast. And as you can see, I'm using Blender 4.5.3, the LTS version, and you see that's when it was actually built. This version I said is from the Flatpak version, it's not from the Fedora repos. I removed the one from Fedora repos. I explained why earlier today. And you see it's GLTF 2.0 export, and you see how long it took, very fast. You can see the time here. What is that, like a second? According to this, it's even less than a second. Yeah, so it was really easy, go so very fast. So I'm going to open up this blend file. I can just double click on it. It should open up in Blender, which it does. As you can see here, I'm going to zoom in. There we go. So that's our table here, and you can see it's the same thing. And while I'm here, what I said before is if you go to file export, you see here you have the GLTF 2.0. So it exports the GLB, which is a binary, or the GLTF. So if I click on this, you can see, then you can throw around with the this one is binary by default because obviously that's what we've done, but you can see the drop down for format. There's also the separate GLTF, the bin and the textures. And then this one, if there's by default animation is checked, which is perfect fine. You can also add other things like copyright, etc. I said I did it on the Python. Okay, so if you want to see the shading, obviously you just go down here to you can click the shading, viewport shading. This is what it looks like, or you can also click on this one, which is another viewport shading, the rendered version. So how the rendered version will look like. There's no camera, there's no light, that's why it's dark. However, if you go to the shading tab, where's here the shading tab here, sorry, shading workspace, you can see what it looks like. It's using the default what do you call it? It's using the default environmental item, which is the forest. So you see the forest, it looks a little bit different. And so that's what I want to show you guys. If you want to model by yourself, it's very simple. It's just cables and two planks. Obviously, there's the middle one part there which hold everything together. So if you have the Python code, you can go to the scripting tab, click new, paste your code in here, and then it will generate the same thing. And also save the blend file and export the GLB file as well. So I'm going to close this, as I think that's a good explanation for what's going on there. Now, with this, so all you need to do, you can't simply drag this HTML file into your into your web browser, because remember we're using a CDN, so you actually need a web server. You can use any web server you want. We just need what do you call it? We just need HTML. So you need so any web server that can serve HTML is the one we need. So I'm going to use Python. So Python space -m space http dot server, and then then the port number I want to use is 8000. As I said, you can use Node.js, you can use Apache, Nginx, anything you want, PHP, anything you want. So the reason I do this is because you see it's 0000, so that doesn't restrict me. I can use localhost, I can use 127.0.0.1, I can use the IP address of the workstation. That's good, because then I'll be able to use it on a phone or another device as well. Okay, so what this means is that I can go to this, I thought I had a, looks like I did not. Okay, so I'm going to use a Chromium browser here. Let me grab the name. I'm going to grab this name. Okay, so what you do is, I know the IP address of my workstation, so that's what I'm going to use. I think it was 8000. I hope it was 8000 slash that dot html. Yeah, see, there you go. And you see this is a web browser. You see my hands here? You'll see it's spinning by itself. This is my, those are my hands there. So it's spinning by itself, but if you want to use the mouse, you can also, you see, you can rotate it any way you want. If you notice here, there's this struts there, lots of places as well, the join, and you see. So the reason I use the HDR image is because it just gives it better color than the boring. This would have been just yellow, so it would look very plain. But because I'm using an HDR image, you see it looks more realistic. The lighting looks also more realistic, and this is a very simple, as you said, this. So some people accuse me of not really doing low poly. I don't know how you call this. This is like the most low poly. What do you call it? It's just a, think about it. It's just a cube, flattened. That's low poly. There's no what do you call it? There's no grooves or anything like that. It's as low poly as you get. What makes it look really nice is just the HDR image. Okay, and even this is just a very simple math. Again, I don't know why people who think this is not low poly. This is clearly low poly. You can make it more advanced, but it is low poly. So low poly doesn't have to look really hideous, right? Like I said, that's why I'm using the HDR light, and yeah, so low poly doesn't have to be. I don't know why people think low poly has to look so hideous. It looks like it's graphics from the late 80s or early 90s. No, you can make things look decent, right? And I said, if you put more effort into it, especially when you use textures, you can really make some really amazing low poly things. Now, just because you have a powerful computer, you have to remember that not everybody does, especially on especially mobile devices. And for example, if you just have one, you can get away with it. But if you have multiple, for example, if I have multiple of this, they're all rotating or falling in each other, physics, of course, that's why low poly is very important, because it will use less resources, less GPU. So there you go. That's essentially the tutorial. And I said you can use the mouse to rotate and etc. You can spin it as fast as you want. So I'll let that go, and you can finish up this tutorial. So I do have resources if you want to keep learning. If you're ready to dive deeper into Python and Blender scripting, you can check out these resources. I have books. For example, I have the Learning Python book. It's a comprehensive guide to Python programming for beginners. You can find it on Amazon. I have the link also in the description. And then I have the Mastering Blender Python API book. You take your 3D automation to the next level with in-depth Blender scripting knowledge. It's also available on Amazon, and they have a direct link also in the description. And a lot of tutorials I did earlier this year were based right. I copied them right from the book. Okay, so you'll be able to follow. Now, obviously, since then I have done other things just to show you that you can get the basic concepts and the examples from the book. Both books, they're lots of examples. So after the introductory phase, lots of examples. So you can go and start scripting right away, whether it's Python or the Blender Python API. So for the Mastering Blender Python API, you can do, what can you do? You can do not just 3D models, we can also do the VSC. So those are two things. The only thing missing is the grease pencil, but I'm working on that. That's in the Mastering Blender Python API. You can also, the Mastering Blender Python API book, you can also create your own plugins. Okay, so both books are available, I said, on Amazon, both in paperback version and the ebook version. The ebook version, if you're using Kindle Unlimited, is free. Okay, and I also have a course called Learning Python that's available on jumboshop.com. The link is also in the description. And if you want one-on-one tutorials, if you need personalized help with Python, including the Blender Python API, I'm available for one-on-one Python tutorials. You can contact me directly at ojambo.com/contact. The link is also in the description. And happy coding and happy modeling. With that said, a quick reminder, I do a live stream every day at 2 p.m. Eastern. Simply go to ojambo.com, click on the watch menu, then live submenu. You can see the topics for this and upcoming tutorial. You see, it also tells you the date and time. So it's 2 p.m. Eastern. Also, be sure to subscribe, like, follow, and leave comments. It helps the channel grow. It helps other people find content like this, and they can improve their coding skills. So in this particular case, it's Python, or maybe they are not aware that there's a lot of stuff you can do just plain Python and the Blender as well. And also, I do have 2 other resources I've been plugging this month. As you guys know, I'm in a rural area, so the internet here, including cellular service, is not very good. In fact, there's none. Okay, so I do use SpaceX Starlink, and I've been using it for over 2.5 years now. It's been fantastic. In fact, this live stream is using SpaceX Starlink. So it works extremely well. Even in, I was worried about harsh weather, but this past winter was very abnormal. It was harsher than usual, and I had turned off the the snow melt feature, but it never froze, and it kept on working even when snow was way above my knee, because I had to go out every day to check on the chickens twice a day, give them water. I had 9 chickens at that time. They had become adults, so I had to be out every day. They drank a lot of water, so I feed them, water them, and all that, make sure they're warm enough. So the internet was perfectly fine. And then I also use it for my phone, Wi-Fi calling. So if you don't know what Wi-Fi calling is, you can use Wi-Fi calling to make calls as if you're in an area where you don't have to pay roaming fees. So you can receive text, including MMS, using your phone, and it's worked great. All right. Also, the last thing I'm going to promote is I have a novelette. It's called The Algorithmic Serpent. It's available on Amazon in paperback and ebook form. And again, if you have Kindle Unlimited, it's free. You see, it's about a scientist who creates an AI system, and he loses his mind. So not only does he have to regain control of his own mind, he has to regain control of the system. So as you can see, this is the paperback version. It's available right now on Amazon all over the world. There's also, as I said, there's an ebook version, and if you have Kindle Unlimited, you can get it for free. Let me know how you guys like this one, because this is obviously it's not a programming book. It's a psychological thriller. So I would like to create more of them. So what I did is I just created a novelette, not a full novel. It's a novelette. And I just to try it out, and I made it extremely affordable. I make very little money from this. I think I make like 50 cents or so from the ebook, and I also make maybe $1 or 50 cents or something like that from the printed version. So the reason I did that is I just want to get it out and see what you guys like. If you don't like, let me know. I said I'd like to make something like that in the future. I do like writing. All right, so with that said, I'm going to check the live chat. I don't see any chat requests, so I'm going to end this live stream, and I'll see you guys tomorrow at 2 p.m. Eastern. The weather has been it's been cloudy. Looks like the drizzling all day. So that what that means is that I probably won't spend that much time outside. I'll just let the chickens out for a little while. So I might do a live stream tonight. I'm not sure the topic yet. Oh, you know what? I think I might talk about Blender. Since this is a Blender tutorial, I'll talk about Blender. I'll show you how I managed to speed up my video renders by 3 times. And actually save space. So maybe that's what I'll talk about tonight. Okay, with that said, I will end this, and I will see you guys at